All right, so this is a little bit advanced because it's something that you study when you get into pre-calculus and math analysis, but we do show it to you in geometry as well because this is what we call a special case triangle. So if we look at this special case, I'm going to move all the way over here so I have some free room. And we're going to talk about the 30, 60, 90 triangle. And a 30, 60, 90 triangle is exactly the way it sounds. One of the angles is going to be 30 degrees, the other angle is going to be 60 degrees, and the last angle is always 90. And what's so special about this? Well, the cool thing is if I know the side opposite the 30-degree angle, so for example, if I say that this angle, this side here is 2, let's just call it 2, then the hypotenuse, the longest side, is always going to be twice as long. So that's really easy. So that means I can just throw a 4 up here. So those are always going to be the same. So if this side were 3, this would be 6. If this were 4, that would be 8. And then the side opposite the 60-degree angle is just this side times the square root of 3. Now, we'll talk about what we do with that later. The square root of 3 is really 1.717, so we can convert it if we'd like. So this is a really helpful little ratio. And if I reduce it, it's 1 square root of 3, 2. That's the ratio, right? So we're going to use that in some examples here. If we look at this first one, you'll notice I'm only given one side here, and we can't use the Pythagorean theorem unless we know all 2 out of 3 sides. So I just showed you that if we know the side opposite the 30-degree angle, we can find the hypotenuse. So in this case, x has to be twice as large, so x is going to be equal to 2. And the side down here is always going to be this side times the square root of 3. So this is going to be 1 times the square root of 3, or 1.7. So that's x and that's y. Now, if we look in the next example, you'll notice that we weren't given any of the sides, only the hypotenuse. So we're going to start off with this 9 here. Well, what do we know about this side here? It's going to be half of the size of 9. So what's half of 9? Well, A is going to be 4.5, right? 4.5 is half of 9. And B is going to be 4.5 times the square root of 3. Now that's not a very helpful number, so I'm going to multiply it out. 4.5 times 1.7, because 1.7 is the square root of 3. So if I go back to my calculator, 4.5 times 1.7, I'm going to get 7.65. So the third side here is 7.65. So when you're working with decimals, I always suggest just make everything into decimals. On our last example, what were we given? We were actually given the side opposite the 60-degree angle. So this is actually a case where we have to do some, this is actually the most difficult case with the 30, 60, 90 triangle. You'll notice the side opposite the 60 does not have a square root of 3 on it. So we have to go back to this ratio here. What happens if the square root of 3 is not present on the 60-degree angle? Well, that means it must have been divided out onto the other sides. So to find the value opposite the 30-degree angle, so it's going to be, in this case, D is going to be equal to 25 divided by the square root of 3. And so that's going to be 25 times the square root of 3 over 3. Don't sweat it if you don't understand that. We can convert this to a decimal in a second. And C is going to be twice that size, so that's going to just be 50 square root of 3 over 3. Now the question is, what's the square root of 3 over 3? It's 1.7 divided by 3. So if we just take 1.7 divided by 3, we get 0.566, and if we multiply that times 25, we're going to get 14 and a sixth. Still not sure why this is giving me fractions, but it's okay. So this is going to be 14 and 1/6, and if we double that, we're going to get 28 and a third. I'm just going to leave it like that for now. That's the 30, 60, 90 triangle. So let's look at a couple other applications of it. If you notice down below for number 4 here, actually in this case, looks like we're being given not the 30, 60, 90, we're actually given a 45, 45, 90. And I haven't taught you that yet. So the 45, 45, 90, the relationship is 1, 1, square root of 2. So if these two sides are the same, this third side is just going to be 8 times the square root of 2. For example, number 5, you notice both sides are the same. And again, this is this alternate case. So y in this case is going to be equal to 28 times the square root of 2 over 2, which is just going to be 14 times the square root of 2. In the next case, we have the side opposite the 60-degree angle. So we're looking for the other sides. We're looking for x. So x, as you recall, is going to be equal to 2 times 14 times the square root of 3 over 3. And again, I realize this is something that you're probably shaking your head at right now. But don't worry. This is just something that we like to show you in geometry. But later you'll get to see it. If you end up in pre-calculus, you'll probably, or in algebra 2 next year, you'll see more of this. Don't sweat it if you're not getting it right now. For number 7, all of these are the square root of 2, so that tells me that my hypotenuse is going to have to be square root of 2. So all I have to do is use the Pythagorean theorem here. So I can say the square root of 2 squared plus the square root of 2 squared equals z squared. Well, the square root of 2 squared plus the square root of 2 squared is just going to be 2 plus 2 equals z squared. And we end up with a pretty easy answer here. Z ends up being the square root of 4, which is just 2. So that worked out pretty cool. If we look at number 8, we've been given the hypotenuse, so it's pretty easy to get x. X is going to be half of that, so that's 15. And the side opposite the 60 is going to be 15 times the square root of 3. And then in my last example, I have a square, and again, I can use Pythagorean theorem here. I can say that s squared plus s squared equals 6 squared. So that's 2s squared equals 36. So s is equal to the square root of 18. And the square root of 18, I'm going to use my calculator. I end up getting 4.24. So s comes out to be, once I get my screen back, 4.24. And so that is special right triangles. But I will say the most important thing that you needed to get out of this week is basic use of the Pythagorean theorem, which are these examples I did in the previous videos. The 30, 60, 90 triangle, not as important, but certainly something that does come up a lot in more advanced mathematics later on. But the Pythagorean theorem, the most important thing that you're supposed to be getting out of this section.